Okay, so we have two functions here. Add, which basically sums up all the values that is in a tree, and swap, which recursively swaps the two subtrees. So it takes the left and the right subtree, swaps them, and then calls swap on those as well. What we want to prove is that for all trees T, the addition of all the elements in the tree is the same as all the elements if the tree was swapped around. So I have to state and prove the base case goal. Well, that's just going to be, we have to prove add null is the same as add swap null. So that's my base case goal. So let's prove it. So add swap null is, well, what's swap of null? Swap of null is null by rule S0. So we get add null by S0, and we're done. That's the whole proof. State the inductive hypotheses. We need to assume that the property is true for two subtrees. So my first inductive hypothesis will be that it's true for some tree L. My second inductive hypothesis will be that it's true for some tree R. So I'm going to label these. I call this IHL and IHR. And then I have to state the step case goal, including a quantifiers, and prove it. So I've got to prove it for a tree built out of these two subtrees. So my step case goal is proving it for node LXR, and the same over here, where L and R are the same trees in the inductive hypothesis, and X is an arbitrary element. So I guess we have to universally quantify X. I have to prove for all X this property here. So I guess I'll start from the right hand side and work my way to the left. So I'll just bump this up here to the top. Okay, so let's start on the right. What's this thing equal to? So what does swap do? It returns the tree with the children swapped. So we have add of node, swap the right, X, swap the left by rule S1. And then we can evaluate the add function. So add of a tree is the root node plus the sum of the two children. So X plus swap R, add swap R I should say. Add swap R plus add swap left by rule A1. Okay, now I can use my inductive hypotheses. So these two statements here, add swap R is the same as add R, and add swap L is the same as add L. So this will be X plus add R plus add L by both inductive hypotheses, IHL, IHR. And if I use the definition of add backwards now, I'll sort of build the tree in the wrong order. So what I need to do is to swap these two first, because addition is commutative. So that's true by maths. And then I can use the definition of add backwards. So this is the same thing as add node LXR by rule A1. And that is equal to the left-hand side. So therefore both sides are equal. And that finishes question 3a.